All right, welcome to week 11 lesson. So we're going to start out today talking about angles. So there's three types of angles that we're going to discuss. We have acute, right, and obtuse. Now these are just kind of definitions. Acute means that it's less than 90 degrees. Okay, so an angle that's less than 90 degrees is called an acute. Right is one that's equal to 90, and obtuse is one that's greater than 90. So for example, 103, that would be obtuse, or acute would be something like 13, because that's less than 90. So first thing we want to define is what it means to be a complementary angle. So two angles are complementary, okay, if they add up to be 90 degrees. So angle 1 plus angle 2 equals 90 degrees. That's what it means to be complementary. Okay, so two angles are supplementary if they add up to be 180 degrees. Okay, so if the two angles add up, if the two angles add up to equal 180 degrees, we call them supplementary. Okay, easiest way to remember that is that the word complementary starts with a C and supplementary starts with an S. And if I take the C, I can turn it into a 9, as in 90 degrees. And I can take my S and turn it into 8 in 180 degrees. So complementary, 90 degrees, supplementary, 180 degrees. So quick example. Let's say you're working a problem and you know that angles A and B are complementary. Complementary. And you know that angle A is equal to 3x degrees and angle B is equal to 6x minus 10 degrees. Okay? You could basically find x, or you could find the measure of each angle. So remember, what you want to do is we want to be able to write a formula. So we know that angle A plus angle B equals 90 if I add them together. That's the formula. Okay, that's really the only hard part. Then you just plug in what you know. Angle A is 3x, angle B is 6x plus 10, and we know that equals 90 degrees. Okay, so all you got to do is solve that equation. It'll tell you what x is. Now you need to make sure you answer the question. So if they ask for angle A, you do 3 times x. If they ask for B, you do 6 times x minus 10. If they ask for x, you just tell what x is. Okay? So just set up the equation, solve, and answer the question. Same thing we talked about last week. All right. So next thing we're dealing with angles is going to be what we call an angle bisector. Okay? Angle bisector is a segment, or it could be a line that cuts an angle in half. Now, if you cut something in half, both of the parts are the same. Okay, so let's say we've got this angle bisector here to where this and this angle are the same, because this, I'll do it in blue here, this is our angle bisector. It cuts this, what I'm going to call the green angle. This green angle gets cut in half by the blue angle bisector. Okay, so what we know is that if I'm going to call this angle C and angle D, I know that angle C is equal to angle D. Okay, so again, if I had some sort of example where this was 3x minus 12 and this was negative x plus 4, I would write the equation 3x minus 12 equals negative x plus 4. Okay, now kind of a weirder example might be if they only gave you 1, but then they told you that the total angle was 16x minus 7. Well, what you would do is you would say the small angle there, angle C, plus angle D, which we don't know, but we know it's the same as angle C. So you could say angle C plus angle D equals the total. So that's the other kind of question they could ask you, is if they only give you one part and they tell you the total and you're supposed to know that this plus this equals the total. Another way to do that with an angle bisector. You just got to remember that C and D are the same. Bisect means to cut into 2 equal parts. So you know that those 2 parts are the same. So you can set them equal, or you can say they add together to be the whole. A couple different ways you can see that given. All right. All right, so now we're going to talk about a special kind of angle called a vertical angle. Okay, so if we have these 2 lines that intersect, we can call this angle A and angle B. and angle C and angle D. Well, I know that angle A is equal to angle B. These are called vertical angles. So I'm going to kind of color code them here. Angle A and angle B are the same, and angle C and angle D are the same, okay? And these again are called vertical angles when they're sort of across the way from this intersection of two lines. So all you got to do is know that you could set up an equation that says, you know, if C was 3x and D was x plus 7, you could say that 3x equals x plus 7. Okay? Just remember that vertical angles are equal. All right? All right, so the next angle pair that we want to talk about is a linear pair. All right, the word line is in the word linear. So basically, it's two angles that form a straight line. All right, so they have to be touching. They have to be kind of adjacent to each other. Sometimes we use the word adjacent. So angle A and angle B, as you can see, together, they form a straight line. Okay, well, what do we know? We know that a straight line halfway around a circle is 180 degrees. So what we know is that angle A plus angle B is equal to 180 degrees. So again, this is how we set up our equation. We use this equation here. If we knew A was 3x minus 1 and B was x plus 6, we would say that 3x minus 1 plus x plus 6 equals 180 degrees. Okay? That is kind of the idea there with linear pair. These are supplementary angles, but they have to be touching. So supplementary could be this angle here and this angle here. These are supplementary. They're not next to each other. They're just kind of wherever. That means they add up to 180. Linear pair means they're back to back. They're sort of pressed against each other and they make a straight line. So they are supplementary, but this is a little more than just saying supplementary. This means that they're next to each other. Okay? So sort of an add-on to that would be something where 3 lines intersect at a circle or 4 lines intersect at a circle. It doesn't really matter how many. But what you know is that in a circle, there's 360 degrees, right? If I go all the way around the circle, it's 360 degrees. So if this is angle A and B and C and D, E, F, G, and H, well, then I can say that A plus B plus C plus D plus E plus F plus G plus H is equal to 360 degrees. Okay, if it makes a full circle, it's 360. I could also say anything like this. I could say, well, B, C, D, and E make 180 because they're a linear group. Like they make a straight line. So those add up to be 180. Or any pair of these 4 would add up to 180. So just again, these are things that we want to be able to do is set up equations to solve for the variables to then answer the question. All right. So what happens if we have parallel lines, okay, with a transversal? So I'm going to mark this as parallel. Now, they don't always mark that as parallel, but these little, you can have 1 or 2 of these little arrows. That means that these 2 lines are parallel. They could also just say L is parallel to M. And if they labeled this L and M, then you would know those 2 lines are parallel. Or you could have, you know, points. So this is A and B and C and D. They could say that AB, line AB, is parallel to line CD. Another way to put that. Okay, so they could have coordinates or points that they're talking about. They could just tell you that this line is parallel to this line, or they could use these little tick marks to show that. But either way, this is what we're going to talk about, is parallel lines with a transversal. Okay, now transversal sounds real scary, but all it is a line that crosses across lines. So here's our parallel lines. I'll mark those that. That would be my transversal. So this line is my transversal, right? And these 2 are my parallel lines down below. Okay, so if a transversal crosses parallel lines, there's all this stuff that you can say, okay? So first of all, if, we'll call this L and M, okay? If L is parallel to M, then you can say all these things about it, okay? All right, if I look at this intersection here, I've got acute angles. I've got 4 of them. See how those are less than 90 degrees? They're kind of small. And I've got 4 obtuse angles, so the ones that are bigger than 90 degrees. Okay, if these lines are parallel, then all the acutes equals any other acute. Doesn't matter which 2 you're talking about. any of these acute angles are equal to any of the other acute angles. So anything red is equal to anything red. Also, any of the obtuse angles should equal any of the other obtuse angles. Okay, now remember, this is only if these two lines are parallel. If these two lines are not parallel, right, this is parallel, this is not parallel. If they're not parallel, this is not going to work. This only works if they're parallel. So all the acutes are equal, all the obtuse is equal, and any acute plus any obtuse is going to equal 180 degrees. Okay, any blue plus any red is going to equal 180 when you add them together. All right, that's if the lines are parallel. Now also, if these things happen, so if all the acute angles are equal, or if all the obtuse angles are equal, or if the obtuse and all the acutes add up to 180, then you can say that the lines are parallel. So this thing works in both ways. They can say, all right, these lines are parallel, tell us what you know. Or they can say, hey, these things are equal, then what do you know about the lines? Well, you can say they're parallel. So we'll look at some examples of that. Okay, let's say this is 60, and I want to know what this is. And it tells me that the lines are parallel. Okay, so first off, if this is 60 degrees, that is one of my acute angles, right? That means all of these guys are going to be the same. Okay, it kind of works diagonally, like these ones and these ones are the same. So that means this one's 60 and this one's 60 and this one's 60. Well, what do we know about these two? These are linear pairs, right? They make a straight line. So that means that 60 plus the question mark has to equal 180. Okay, it's because these lines are parallel I can say that. Well, if I just solve for the question mark, if I take away 60, I get 120 degrees. So that means that unknown angle there was 120 degrees. Okay, so that's one that's kind of basic. They could usually make it a little bit harder, where they usually have something like 3x minus 12, and maybe this is x plus 6, okay? But as you can see, these are my acute angles, acute angles, acute angles, acute angles. So all the ones with dots are acute. So if they tell me that L and M are parallel, they say, okay, L and M are parallel, what do you know X is? Well, we can set up an equation. I've got an acute here and an acute here. They must be equal to each other. Okay, solve that equation, you're going to get what X is, and then answer the question. Do they ask for what this angle is or what this angle is maybe? Or maybe they just ask for X. But whatever they ask you for, then you use that X to answer the question. Okay, they either ask for X or they ask you for the measure of an angle, and you use that X to find the measure of the angle. Okay? Now, alternately, that's sort of the first case, is that they could tell you that the lines are parallel and ask you to solve for something or to figure out some information. Alternately, they could do something like this. They could say this is 60 and this is 60. What do you know about the two lines? Well, you would say that line L is parallel to line M. Okay, that's a question they could ask as well. Alternately, maybe this wasn't 60, maybe this was 58. What do you know? Well, I actually know that line L is not parallel to line M because those should have been equal. These are actually my obtuse angles, so it's kind of bad I put 60. Maybe I should put 100 or something, and this is 98. But because my obtuse and my obtuse aren't equal, that tells me that these lines are not parallel. Okay, now the other thing that they'll do is they'll give you two sets of parallel lines like this. Okay, they'll say parallel here, parallel here. These are parallel as well. It works the same way. If both sets are parallel, then you know that any obtuse is equal to any obtuse. All the obtuses are going to be equal here. All the greens are going to equal all the greens. And all the purples, all the acutes are going to equal all the acutes. And you know that any green plus any blue is going to add to 180. Okay? It works the same way. Now, if one of them are not parallel, so maybe you've got one set of parallel lines and then a pair that aren't, you got to be careful. You can only deal with one transversal at a time. So you know that this acute and this acute, and these obtuses are all equal, and we know that these acutes are all equal, but we don't know anything about anything here related to anything here. We just don't know that, okay? I can say that, all right, I'll use some different colors here. All these are gonna be the same, and all these are gonna be the same, but we don't know anything about red to yellow. or red to black, or green to yellow, or green to black. We can't make that relationship because of these lines not being parallel to each other. So really, you can only focus in on the parallel lines and one transversal at a time. If all the things are parallel, then you can connect the dots on everything. But really, only focus in on the parallel lines and one transversal. Don't focus in on two transversals that aren't parallel and then one line that crosses those. That won't work. Okay? All right, so we're going to go on to triangles. Remember, anything with three sides and three angles is what we call a triangle, right? Okay, so remember, an acute triangle, right? Something sort of like this. None of the angles here, no angle greater than 90. They all have to be acute. An acute triangle has all three angles that are acute, okay? If you have what's called an obtuse triangle, it means that one of the angles are bigger than 90. So one obtuse. You can't have more than one obtuse because the interior angles sum to 180. If you had something bigger than 90, you couldn't add something bigger than 90 to that. You get too much. So you can only have one acute. And then, of course, a right triangle is one that has one angle equal to 90 degrees. And of course, you can't have more than one right angle because that's 90 plus 90. You have to have room for a third angle, so that wouldn't work. Okay, so here's some definitions for you. The three types of triangles we're going to talk about. One is called scalene, all right? And one is called isosceles, and one is equilateral. All right, so scalene triangles have no equal sides. None of the sides are equal. You have to actually have all three sides different lengths. You cannot have two sides that are the same, which also tells me that none of the angles are equal, okay? No equal sides and no equal angles. All right, so isosceles, iso meaning isolate, it means one of them is off by itself, which means that really two of the angles are equal and two of the sides are equal. So you have two equal sides, two equal angles. That's what isosceles means. One of them is different, right? It's isolated. Equilateral, all three sides are equal. And of course, that means all three angles are equal. So there is a relationship between side and angles here when we're talking about triangles. And what that comes from is, think about a very small angle, okay? The length of that opposite side is going to be small because of that small angle. If you had a very big angle, obviously it would make a bigger opposite side. And if two angles are equal, like for example, if this angle and this angle are equal, what it tells me is something about those opposite sides. Those opposite sides then must be the same length. Okay, so small angles give me small opposite sides. Large angles give me large opposite sides. And equal angles give me equal opposite sides. Okay, that's why in an equilateral triangle, all the angles are the same. It has to do with the sides are all the same, excuse me. It has to do with the angles, all right? So here's some properties of all triangles. So all triangles in the whole wide world follow these properties, okay? First off, the area is always 1/2 base times the height, okay? When I'm talking about the base, I'm talking about whatever's on the ground. That's the length of the base. The height is the vertical distance up to the very top point, okay? Also called the altitude, all right? But if you've got a triangle on its side like this, okay, remember the base is still from here to here, but the height is actually from here to here, okay? It's the height, the highest point straight down to the ground. All right, so that's the first property, is that the area is always 1/2 base times height. All right, the other thing is that all three angles add to 180. All three angles of a triangle add to 180 degrees. That's the second property that you got to know. All right, the last thing is that the two smallest sides add together to be greater than the largest side. So what I mean is like the small side plus the medium side has to be greater than the large side. When you add the two smaller sides together, they have to be bigger than the larger side. Okay, and what I mean by that is think about if you had one really big long side like 20, and this right here was 6, and this right here was 13, right? Can you see how these two sides are never going to actually touch, right? It's only going to be like this side 13 folds down to here. This 6 only goes to here. There's a gap. So they're never going to actually touch. So it has to like withstand to where the smaller two sides are bigger. Now, how they're going to ask you that on the ACT is they're going to say, can a triangle have sides 3, 6, and 9? Well, the two smaller sides, when you add them together, have to be bigger than the largest side. And that's not true. So that means you cannot have a triangle with those length sides. How about 12, 15, 16? Yeah, the two smaller sides, when you add them together, they're bigger than the largest side. So that's okay. You could have a triangle with 12, 15, and 16. It's called the triangle inequality theorem. They just have to be bigger together than the largest side, the two smaller sides do. All right, so moving on to right triangles. Right triangles. You'll see I use this abbreviation for triangles a lot. It's just a long word. This is just a little bit faster. So first thing we're going to talk about is Pythagorean theorem. Okay, everybody knows Pythagorean theorem, but you got to know it in a special kind of way. Okay, if you have a right triangle, first of all, that's the first part. It has to be a right triangle. Then we know that a squared plus b squared equals c squared. And of course, what that comes from is a right angle. C is always the side that's the hypotenuse across from the 90. A and B are what we call the legs. And they are just, it doesn't matter which one is A and which one is B. But this is what we say. If it's a right triangle, then we know the length of A squared plus the length of B squared is equal to the length of C squared. Okay? Now, the other part, the part that, you know, not everybody thinks about is if a squared plus b squared equals c squared in a triangle, then what do we know? Well, then it means it's a right triangle. Okay? We're all familiar with this kind of problem. 6, 2, find x, right? Sure, a squared plus b squared equals c squared, and we solve for x. But what about this? Or is 3, 4, 5 a right triangle? Well, how do you prove it? If you have a side that's 3 and another side that's 4 and another side that's 5, is that a right triangle? Well, you just plug it into Pythagorean theorem. Because if this holds, then you know it's a right triangle. So you try it. 3 squared plus 4 squared hopefully will equal 5 squared. Well, 3 squared is 9, 4 squared is 16, 5 squared is 25. It's true that 9 plus 16 equals 25. Therefore, 3, 4, 5 is a right triangle. Okay? Is 5, 9, 16? Well, first of all, that can't be a triangle. That's a bad example. How about 5, 9, 11? Let's try it. A squared plus b squared equals c squared. You get 25 plus 81 equals 121. That is going to be 106 equaling 121. It does not work, so it's not a right triangle. So you can prove that something is a right triangle using Pythagorean theorem. Now, interestingly enough, what do we know about this 5, 9, 11? Well, remember my a squared plus b squared is my a and my b. If my c squared is if it's just right, it's going to be a right angle. If my c squared is too big, can you see how it's going to be an obtuse? So if C gets too big, then it forces that angle to be bigger. It stretches it out. So if the C is too small, you can see how, here's your A and your B. You can see when C is small that you get an acute angle there. So really, you can say that if a squared plus b squared is less than c squared, meaning c squared is big. If c squared is big, that means it's an obtuse triangle. All right, and if a squared plus b squared is bigger than what c squared is, it's going to be acute, because it's all about c. If c is too big, then it's obtuse. If c is too small, it's acute. If c is just right to where it's equal, then you get a right triangle. Okay, so I've definitely seen questions like this, like here's three sides of a triangle, is it acute or obtuse? So you're supposed to use Pythagorean theorem, but then think about how c getting bigger or smaller affects the angle. Okay, all right, so there's some Pythagorean triples that we got to talk about. Okay, Pythagorean triples. Triples just means three, so we're talking about three numbers, and these three numbers are what we plug into Pythagorean theorem to hold true. What that means is that if you have a 3, 4, 5 triangle, it's a right triangle. It's one of those Pythagorean triples. These three whole numbers work with a squared plus b squared equals c squared, therefore they form right triangles. So it's just one of those you should memorize, because you'll see problems like this all the time. This is 3 and this is 4, and they want you to find x. It's 5. It's a 3, 4, 5 triangle. Okay, if it's a right triangle, it's 3, 4, 5. Or sometimes they won't give you this, and they'll say find x, and this will be 5. Well, it's a 3, 4, 5, so this x has to be 4. So you have to remember 3, 4, 5 triangles. They are so quick, and they are all over the test. So you got to look out for them. The other one is a 5, 12, 13. That's a really common one as well. There's others, but these are the two that they use the most on the ACT. So if I saw a triangle that I knew was a right triangle, and this was 13, and this was 5, I wouldn't even waste my time using Pythagorean theorem. I would know that that's a 12. It's a 5, 12, 13 triangle. Okay? Now, not only does 3, 4, 5 work, but any multiple. So if I were to make this a 6, 8, 10, it would work as well. That's a multiple of 3, multiple of 4, multiple of 5. So if I double 3, 4, and 5, I get 6, 8, 10. That's going to be a Pythagorean triple as well. So if I double that, or triple the 3, I triple the 3, I get 9, triple the 4, I get 12, triple the 5, I get 15. That's also a Pythagorean triple. So you can see any multiple of 3, 4, 5 is going to work. So if I saw a triangle and this said 30 and 40, I would know what this has to be. It has to be 50, because it's 3, 4, 5, but just times 10. Okay, same thing with this. If this was 50 and 130, I would know this is 120. It's the 5, 12, 13 as a multiple of 10. So those are your Pythagorean triples. You've got to memorize those. They're going to be on the test. They put them on there for sure, and they will definitely save you time. So make sure you're memorizing that 3, 4, 5, and 5, 12, 13 right triangles. Okay? So continuing on with right triangles, we've got some special right triangles that we want to talk about. Okay, these are definitely going to be shortcuts. You don't have to memorize them, but they will save you time. And that's kind of our goal here, is to save time. So first off, 45, 45, 90. Okay, here's how 45, 90 works. First of all, if this is 45 and 45, I know that these two opposite sides are equal. Okay, it's an isosceles triangle. Remember, opposite sides are based off of the opposite angles. So since those opposite sides are equal, or these opposite angles are equal, that means the opposite sides are equal as well. So let's call this 1 and 1. Now I can use Pythagorean theorem to find the length of the hypotenuse, but I don't need to. I can memorize what a 45, 45, 90 triangle's relationship is. So it's 1, 1, and this is square root of 2. Okay? So basically, in general, I mean, let's look at another example. Let's say this is 5 times the square root of 2. Okay? That means that this angle is 5, or this side is 5, and this side is 5, if it's a 45, 45, 90. Okay? If this is a 45, 45, 90, and this is 10, that means this has to be 10, and this has to be 10 square roots of 2. It's that easy. Okay? You can use Pythagorean theorem, and it'll show you the answer, but this way is much faster. So in general, whatever this side is, it's the same as this side. Okay? So if it's some number x, and the other one is that same number x, this one is that same number x times the square root of 2. Okay? So I remember it as a 1, 1, 2 triangle. 1, 1, 2. So back up here, 1, 1, 2. The last number, of course, is the square root of 2, but it helps me remember. 1, 1, 2. Now, in general, if you know the legs, these sides, you find the hypotenuse by multiplying by the square root of 2, okay? Either way, and these are always going to be equal. Now, if you're given the hypotenuse, you don't multiply, you do the opposite. You divide by the square root of 2, okay? So some examples would be if this is 10, right? This one's tricky. It doesn't have a square root of 2, so I don't just use the number in front. What I have to do is divide by the square root of 2. So 10 divided by the square root of 2. This one is also 10 divided by the square root of 2 because these two should be equal to each other. Okay? Now you won't see 10 over square root of 2. What they'll do is rationalize that. They will multiply the bottom by the root and the top by the root. Basically, we're multiplying by 1. Root 2 times root 2 is 2. On top, you get 10 root 2. And then the 10 and the 2 will cancel, leaving a 5 behind. So really, they'll put 5 square roots of 2 and 5 square roots of 2. But you can always use your calculator to make it a decimal and just see which of the answer choices match. So if you got 10 over square root of 2, you could get out your calculator and say, okay, 10 over square root of 2. That is going to be 10 divided by the square root 2. As a decimal, that's 7.07. So maybe all the answer choices you go through and you see one that says 5 times the square root of 2, and you plug in 5 times the square root of 2, and you see that it's the same thing. So you go, oh, okay, it's just that. So if you're not sure how to rationalize the denominator, you can definitely do it by just kind of guessing and checking and putting everything into decimals. All right, so just remember, if you multiply by the square root of 2 from the legs, you get the hypotenuse, and if you know the hypotenuse and you want to find the legs, you divide by the square root of 2. That's just the only thing you got to remember. All right, so that's our first one. That's our 45, 45, 90 triangle trick. All right, sorry about that. Now we're moving on to our 30, 60, 90. So 30, 60, 90. That is if we have a 30-degree angle, that's the smaller angle with opposite smaller side. 60-degree angle, the medium with the medium opposite side, and of course our 90 with our longest side here. All right, so here's how this one works. It's a 1, 2, 3. 1, 2, 3. Not a 1, 1, 2, it's a 1, 2, 3. The smallest side is 1, the longest side is 2, and the medium side is the square root of 3. Okay, so what that means is we double here, and then this actually is our coefficient 1 here. So you'll see how that works when I change it up. So let's say this is our 60 or 30. Let's say this is 5. Well, we double here to get 10, and then we actually go this way to do 5 square roots of 3. Okay, so you're kind of basing everything off of this 30-degree opposite side. You double here, you multiply by root 3 to get here. Okay, so in general, right, here's your 30 and 60, 90. If this is some number x, this is always going to be double that. Okay, it stems from the fact that this is really just a equilateral triangle. If you think of this other 30, this is 60. So you get x and x, that's 2x. So this has to be 2x because this is 2x. You know, you sort of reason through why that works. But just remember to double here and then to multiply by the square root of 3. So x times the square root of 3. 1, 2, square root of 3. Okay, so 1, 2, 3 triangle. Now, of course, that's if you're given the small side. That's the easiest one. Okay. Now, what if you're given what if you're given the hypotenuse? It's 20. Well, just remember it's half, right? If you double here, you go half back here. So you cut in half here, and then what is this one going to be? Well, it's going to be 10 square roots of 3. So either, depends on which direction you're going. You either double it to get this one, or if you're going backwards, you cut it in half. Okay? So let's try some examples here. All right, I got a 45, 45, 90 triangle, and I know that this is 6 square roots of 2. All right, well, this is the same thing, 6 square roots of 2 divided by square root of 2, which is just 6. And that's just 6, okay? Let's say we've got a 30, 60, 90, and I know that the length of the hypotenuse is 10. Well, remember the short side is always half that, and then this medium side is the small side times root 3. So it's that easy. These should be super quick and easy to do. And of course, if you need practice, we'll just use some practice problems to get better at that. You want to just be really fast at those things. All right, so let's talk about some special segments of right triangles, or just any triangle, I guess, special segments of triangles. All right, first one we'll talk about is the altitude. We just mentioned it, but we'll review it again. It is the height of the triangle, okay? If your triangle is sitting on the ground, the height is the perpendicular distance from the top to the bottom, okay? It's got to be perpendicular. It's got to be a right angle. Of course, the weird example is when it's sitting on the ground here, the height is actually this distance here. Okay, so we're dealing with a lot of right triangles when we're finding the height. So we're usually using sine, cosine, tangent, or we're using Pythagorean theorem or our special triangles. So when you're looking for the height, just remember it's got to be perpendicular. So all of a sudden, you've introduced a right triangle into the situation. So you're using one of those kind of ideas. Okay, and where this comes into play also is the area formula, base times height. Well, that's what we're talking about, the height, the altitude. All right, so the next special segment we're going to talk about is the median. And remember from, I guess, mean, median, and mode, the median is in the middle. So what we're doing is we're cutting one of the sides in half. So we're bisecting the side, and then we connect it to the opposite side. So this is called the median. It goes from one vertex to the opposite midpoint of the side, okay? And what you need to know is if these are 3 points A, B, and C, okay, what we know is that AB is equal to BC. So that's one of the biggest things with median is that you realize that it actually bisects the opposite side to where AB and BC are going to be equal, okay? Because it goes to the midpoint, that happens. So they won't usually tell you that. You're kind of expected to know that, oh, a median, that's what happens with a median is that we go to the opposite side and it bisects the side. Okay. So last thing we're going to talk about, our special segments is the mid segment. Okay, mid segment. All right, so if we've got this triangle, there's so much going on with mid segments, and here how mid segments work. You take a midpoint, right, which means that you've bisected a side, and you connect it to another midpoint. So you bisect another side and you connect them. That's called a mid segment. Okay, now if you connect all three, if you basically bisect all three sides and you connect them, then you have your mid segments. These are your 3 mid segments. Now, first thing that you got to know is that this creates parallel sides, not 11 sides. Remember, that's our symbol for parallel. What I know is that this is parallel to this. Okay, basically, if I connect this, you'll see that this line and this line are parallel to each other. Now that also happens here. This is parallel to this. And of course the third one is this is parallel to this. Now there's a lot going on there. So I'm going to erase some of these just because it's kind of hard to see. But that's the first thing you have to remember is that when we do mid segments, it starts to, you know what, I'm just going to redraw this. So, all right, so midpoint to midpoint to midpoint, these are our mid segments. Okay, so the first thing you got to know is this makes parallel sides. All right, now if we have parallel sides, think about a parallel line with a transversal. You start getting these equal angles, okay? So we'll talk about that in just a second, but that's sort of where the parallel sides come in. Second thing is, remember this and this are equal. It's also the same as this. So the parts that are parallel are equal. So this little piece and this little piece equal this little piece, okay? So what that means is that the side, the small parallel side, is half of the long parallel side, okay? Because it takes 2 of them to make the whole side. So it's twice as long or half as long, depending on which way you're thinking about it, okay? But there's this doubling and halving relationship between those parallel segments, okay? Third thing is obviously it bisects the side, okay? Just by definition, we're doing midpoints, So that means that this and this are equal because we're bisecting that side. That one's a little bit obvious, okay? Fourthly, what we do is we create 4 congruent triangles. Okay, not parallel, or not similar, congruent. This triangle here is identical to this triangle here, and this triangle here, and this triangle here. Now, it's kind of hard to see, but I'm going to use some color coding here to show you. If this side is equal to this side and also equal to this side, right? Well, that means that this side is equal to this side and this side. And thirdly, this side and this side are equal, and they're also equal to this side. You can see these 3 triangles, okay? Now, the 3 that are right here, and right here are kind of like slides. So they're in the same orientation, they're just slid around. On the other hand, this triangle in the middle is special. It gets a different orientation. You have to sort of rotate it into the triangle. So you'll see that if you rotate it, then it's identical. So when we start talking about angle measures being the same, we're talking about things like this. The angle here and the angle here and the angle here are all the same, right? You can see how the slide keeps the orientation the same, but we actually flip it over to this angle here, right? When we flip it over, then it's on the other side. All right, alternately, we can talk about this top angle being the same as this top angle and this top angle, but then on this side, it's actually the bottom angle, right? Because it flips upside down. And then lastly, you know, talking about this angle and this angle and this angle, of course, flips around to that side. But they're all congruent triangles. So the area is the same, the side lengths are the same, the angles are all the same, everything is identical within these 4 little triangles, okay? So I guess lastly, there's a lot of angles that are congruent, and that comes really from the parallel sides. So it means that all these angles are congruent, okay? Again, this is mid-segments. There's so much going on with mid-segments. You can kind of assume stuff about it because it looks like it might work. So you can kind of, it's intuitive a little bit. But that's the last thing I got for you today. We talked about triangles, all the special triangles, right triangles, all the properties. And that's all I got for you today. I appreciate you being here, and we'll see you next time. Thank you.